Here's a lesson for section 3.6, adding and subtracting polynomials. To understand this lesson, you'll have to understand what like terms are and how to simplify by collecting like terms. So if you need a refresher on that, make sure you go back and watch the video for section 3.5. I'll just give you a quick reminder of what like terms are. Like terms are terms that have the exact same variables with the exact same exponents. So we're going to learn adding and subtracting polynomials, so we'll start off with adding polynomials. So, first of all, what is a polynomial? A polynomial is an algebraic expression consisting of one or more terms connected by addition or subtraction operators. We learned that earlier in the unit. Now we're going to learn how to add polynomials together. So I've got a polynomial here. I've got a 4x plus 3. And I've got a polynomial here. I've got a 7x plus 2. I want to be able to add these two polynomials together. When adding polynomials, you can simply just remove the brackets and collect your like terms. So let's go ahead and do that. So 4x plus 3 plus 7x plus 2. I'm going to rewrite that. So step 1, remove the brackets. Rewrite it without the brackets. 4x plus 3 plus 7x plus 2. Now, this is just like what we did in section 3.5. I'm going to simplify this expression by collecting my like terms. To do that, I'm going to first put my like terms into groups. So I'm going to put my 4x and my 7x beside each other. And I put my 3 and my 2 beside each other. So 4x and 7x are like terms because they have the exact same variable with the exact same exponent. So these both have an x to the exponent of 1. So those are like terms. And then constant terms are always like terms. We know how to collect 3 plus 2 together. So let's go ahead and simplify this. If I have 4x and I add 7x, I now have 11x. If I have 3 plus 2 is 5. So I have fully simplified that expression now. And you'll notice when I collected my like terms, when I did 4x plus 7x, the variable and the exponent on the variable did not change at all. I just added the coefficients. 4 plus 7 is 11, and then I kept the variable exactly the same. That's why I have 11x plus 5. So let's practice this a couple of times. So number 1, so I have 3y plus 5 plus 7y minus 4. So I'll notice I'm adding two polynomials. When adding polynomials, I can simplify by just removing the brackets. So I'll do that first, remove the brackets, and then collect my like terms together. So I'm going to group my terms. So put 3y and 7y beside each other. And I put my 5 and my negative 4 beside each other, and then collect the like terms together. 3y plus 7y is 10y. 5 minus 4 is positive 1. I'm going to simplify. I'm going to do number 2 now. So I have 2p minus 2 plus 4p minus 7. So I'll notice I'm adding polynomials. When adding polynomials, I can simplify by just removing the brackets. So I've removed the brackets. Now I'm going to collect my like terms. I'll put them in groups first. Put my 2p and my 4p beside each other. I'll put my negative 2 and negative 7 beside each other. 2p plus 4p gives me 6p. Negative 2 minus 7 gives me negative 9. Next question. I have 6x minus 12 plus negative 9x minus 4 plus x plus 14. So this one has 3 polynomials that are being added together. Let's just follow the same rules. Whenever I'm adding polynomials, I can simplify by just removing the brackets. So I'm going to do that. I'm going to remove the brackets. So I have 6x minus 12 plus negative 9x. So when I have a positive and a negative beside each other, the negative always wins. So I'm going to rewrite that as just minus x, or minus 9x, sorry. Minus 9x minus 4 plus x plus 14. Put my like terms into groups. So I have a 6x, a negative 9x, and a 1x right here. I have, and then I'll group my constant terms together. Negative 12, negative 4, and 14. Now I'm going to simplify this by collecting my like terms. 6x minus 9x is negative 3x. And then add 1x to that, I'm now at negative 2x. Negative 12 minus 4 is negative 16. Add 14 to that, I'm at negative 2. So negative 2x minus 2. And that can't be simplified any further because these two things are not like terms. They don't have the same variables with the same exponents, so I can't simplify that any further. Next one. So in this case, I'm adding two trinomials instead of binomials like in the previous question. So that's fine. Still follow the same rules for adding polynomials. So I know to add polynomials, I simplify by dropping the brackets and then collecting like terms. So let's rewrite this without the brackets. So 5x minus 4y minus 1 plus negative 2x. I know a positive and a negative beside each other turns into a negative. Plus 5y plus 13. Put my like terms in groups. So I'll put my x's at the beginning, 5x. I have a negative 2x. And then I have a negative 4y and a positive 5y. And then the last group, I have a negative 1 and a positive 13. And let's simplify this. 5x minus 2x is 3x. Negative 4y plus 5y is positive 1y. Negative 1 plus 13 is positive 12. And then that's as simple as this gets because none of the three terms that are left are like terms at all. So the 3x and the 1y have different variables, so I can't collect those together, and I can't collect the constant term with either of those either. So when you're subtracting polynomials, there's two ways you can think about it. I'll show you both ways, and then whichever way you like best, that's the way you can do the questions from now on. So the first way of thinking about subtracting polynomials is adding the opposite polynomial. So to subtract polynomials, all you have to do is add the opposite polynomial, and we know how to add polynomials. So basically, in order to find the opposite polynomial, you just switch the signs of the terms in the polynomial that's being subtracted. So if I want to do 3y plus 5 minus 7y minus 4, so I'm subtracting this polynomial, I just need to add the opposite of 7y minus 4. And what is the opposite of 7y minus 4? Well, it said here, just switch the signs of the terms of the polynomial being subtracted. So the opposite of 7y minus 4 is negative 7y plus 4. See how I switched the signs of both of the terms in the polynomial? So I'm going to rewrite this as an addition question instead of a subtraction question. So I have 3y plus 5 minus 7y minus 4. So I know it's a subtraction question, so I'm subtracting polynomials. I can rewrite this as an addition question by adding the opposite of 7y minus 4. So I'm going to keep the first polynomial the same, 3y plus 5. And then instead of subtracting 7y minus 4, I can add the opposite of this. So add negative 7y plus 4. Now I've created myself an addition question that I know how to do because we know how to add polynomials. If you remember, when adding polynomials, all you have to do is drop the brackets. So 3y plus 5 plus negative 7y plus negative 7y. I know a positive and a negative beside each other turns into a negative. So I'll rewrite that as minus 7y plus 4. Now collect my like terms. 3y minus 7y is negative 4y. 5 plus 4 is positive 9. So I've now simplified that expression. So I've subtracted a polynomial by adding the opposite. The other way you can think of this, or you can think of it the way I like to think of it. I like to think of, so if I see a question, 3y plus 5 minus 7y minus 4, so I'm subtracting a polynomial, I think of subtracting each of the terms in the second polynomial. So I'm essentially distributing this negative sign to each of the terms in the polynomial that I'm subtracting. So if I want to do 3y plus 5 minus 7y minus 4, I need to do 3y plus 5 minus, I need to subtract the 7y, so subtract 7y, and I need to also subtract the negative 4. I need to subtract the negative 4. So I've distributed that negative sign to the 7y and to the negative 4. Now I'm going to simplify the signs. Minus 7y. I have two negatives beside each other. Those change to a positive. Now I can collect my like terms. Once again, I have 3y minus 7y. That's negative 4y. And I have a 5 plus 4. That's a 9. Positive 9. So you'll see I got the same answer for both of these questions. Negative 4y plus 9. Negative 4y plus 9. So for the next questions we're going to do, I will probably use this method when I go through the questions. I'm going to distribute the negative sign to each of the terms in the polynomial that I'm subtracting. So if I want to do, I'm going to give myself some more room here. If I want to do 4x plus 3 and then subtract 7x plus 2, I need to subtract the 7x, and I also need to subtract the 2. So let's rewrite this without the brackets by doing that. So the first polynomial stays the same, so 4x plus 3. Now I need to subtract 7x, and I need to subtract positive 2. So when I subtract positive 2, so subtract positive 2, a plus and a minus beside each other simplifies to a minus. So I have 4x plus 3 minus 7x minus 2. I'll group my like terms together for this one. So 4x minus 7x, and then plus 3 minus 2. Then we'll collect our like terms. 4x minus 7x gives me negative 3x. 3 minus 2 gives me positive 1. Okay, let's do this question. We're subtracting polynomials in this question. In this case, we're actually subtracting a trinomial. So, but remember, this negative sign has to be distributed to each of the terms inside the polynomial that we are subtracting. So I'm going to rewrite this without brackets by distributing that negative sign. The first polynomial stays the same. Now I need to subtract the negative a squared, so minus negative a squared. I need to subtract the negative 2a, so minus negative 2a. I need to subtract the negative 5, minus negative 5. So now I'm going to simplify all the signs. You could have simplified in this line if you wanted, if you can see that. So a squared minus 2a plus 1. I have two minuses beside each other. Those simplify to a plus. Once again, two minuses beside each other simplify to a plus. And once again. Now collect your like terms. I'll group them first before I collect them to make sure I don't forget any. So I have an a squared here and an a squared here. I'm going to group those. I have a negative 2a and a positive 2a. And I have a couple constant terms. I have a positive 1 and a positive 5. Now let's simplify. 1a squared plus 1a squared gives me 2a squared. Negative 2a plus 2a gives me 0a. So those are gone. And 1 plus 5 is 6. So that's simplified. Two more before we do an application question. So let's do this one. Once again, I'll notice that I have two polynomials, and I'm subtracting the second polynomial from the first one. In order to do that, I need to distribute this negative sign to each of the terms inside the polynomial that is being subtracted. So let's rewrite this without brackets by doing that. So 3x plus y minus 4z. You'll notice that one doesn't change at all. Now distribute that negative sign to each of the terms. So I need to subtract 7x. I need to subtract 3y. I need to subtract negative 2z. So minusing a negative changes to a plus. Now I'm going to collect my like terms. I'll put them in groups first. So I have a 3x and a negative 7x. I have a 1y. I also have a negative 3y. And I have a negative 4z and a positive 2z. Now let's simplify this. 3x minus 7x gives me negative 4x. 1y minus 3y gives me negative 2y. And negative 4z plus 2z gives me negative 2z. There we go. That expression is simplified. None of these three terms are like terms because they all have different variables, so I can't collect those at all. All right, last one. So I have 6x minus 12 minus negative 9x minus 4 minus x plus 14. So to get rid of the brackets, I'm going to have to distribute the negative sign to each of the terms in this polynomial that's going to be subtracted. And I'm also going to have to distribute this negative sign to each of the terms in that polynomial that's being subtracted. So let's go ahead and do that. So the first polynomial is not going to change, 6x minus 12. I need to subtract negative 9x. Subtracting a negative is adding. I need to subtract negative 4. Subtracting a negative is adding. So let's get rid of these brackets now. So I need to subtract x. And I need to subtract 14. Now let's group our like terms. I have a 6x plus a 9x minus an x. And I have a negative 12 plus a 4 minus a 14. 6x plus 9x is 15x, minus 1x is 14x. Negative 12 plus 4 is negative 8. Take away 14 more, I'm at negative 22. That expression is now simplified. Okay, let's do an application question now. Hopefully we've got a good understanding of adding and subtracting polynomials. So here's our application question. The Birds players get an X amount of dollar bonus added to their base salary for every goal they score during the playoffs. Here are the salaries and goals scored for the 3 highest scoring players on the Birds during the playoffs last season. So Bardown Jensen has a base salary of $1,200, so he gets paid $1,200 no matter what. Then he gets an X amount of dollars added for every goal he scores in the playoffs, and he scored 18 goals. Wayne gets a base salary of $1,300, and he scored 22 goals. Timmy Toedrag gets a base salary of $900, and he scored 5 goals. So let's write an algebraic expression about the amount of money each of those players would earn. So for Bardown Jensen, his earnings, he's going to make $1,200, plus he gets an X amount of dollars for every goal that he scores in the playoffs, and he scored 18 goals. So 18 times that X amount of dollars. Wayne Goal gets a base salary of $1,300, plus he gets the X amount of dollars for every goal he scored as well, and he scored 22. So plus 22 times that X amount of dollars. And Timmy, base salary of $900, and he only scored 5 goals in the playoffs. So let's write a simplified expression for the total amount of money that the owner of the team will have to pay the 3 players at the end of the season. So let's add all 3 of these together. So we're adding these polynomials together. So total amount, so amount equals, I need to add these 3 polynomials. So 1,200 plus 18x plus 1,300 plus 22x plus 900 plus 5. I wrote G that time. I was probably thinking goals. So we're using X for the amount of money for each goal that they score. So 900 plus 5. X. Okay, now I'm adding a bunch of polynomials together. I know I can simplify by just dropping the brackets and collecting like terms. So I'm going to rewrite this without the brackets. 1,200 plus 18x plus 1,300 plus 22x plus 900 plus 5x. Let's group our like terms together. So I have an 18x, I've got a 22x, and I've got a 5x. And my constant terms, I have a 1,200, I've got a 1,300, and I've got a 900. Okay, let's make sure those numbers are all right. 1,200, 1,300, 900. Good. Yeah. So let's simplify by collecting our like terms. 18 plus 22 is 40, plus 15 is 55. So I have 55x. Oh, it should be, oh, that's a 5x. Sorry, not a 15. So I have 18x plus 22x is 40x, plus 5x is 45x. Sorry, that looks like, it looked like a 15 to me there. Now I have 1,200 plus 1,300. That gives me 2,500. And I want to add 900 to that. I'm now at 3,400. So this is a simplified expression for the total amount the owner of the Birds is going to have to pay those 3 players. They're going to have to pay X amount of dollars times the 45 goals those 3 players scored, plus the $3,400 in base salaries. So if X is 25, so if the team is paying each of those players $25 for each goal they score in the playoffs, what is the total amount of money that the owner will need to pay those 3 players at the end of the season? So let me just write my expression again. So my amount is equal to 45x plus 3,400. So to do this, I need to substitute 25 in for x. So 45 times 25, the $25 they're being paid for each goal they scored, plus 3,400. Now when I evaluate this, I need to make sure I do the correct order of operations. So I need to do the multiplication first. So I need to do the 45 times 25, which will give me 1125. And then I want to add the 3,400. So when I add the 3,400, I'm then going to be at a total of 4,525. So the total amount of money that the owner is going to have to pay those players at the end of the season is $4,525. $4,525. And that's it. If you have any questions, make sure you let me know. Make sure you try the worksheet on jensenmath.ca to make sure you understand this material.